Okay. All right, so I'm gonna start this here. We're gonna have someone read while I'm getting ready. They get 20 points. There's a lot to say there. For reading the problem, you can read it from your page, Jamarian, or you read it from the slides if you want to open that up. It's up to you. If you can see it.
Agenda today, we do a CD is paid by shifting a laser beam onto the disk and converting the pattern of reflecting light into the pattern. Sound waves for proper operation of linear
Tangential.
Mm-hmm. Be a disk where the laser beam shines on it must be maintained at a constant value of 7.49 meters per second as the CD is played. The laser beam scans the disk in a spiral track beginning near the center and proceeding outward to the rim. What angular speed must a CD have when the laser beam is shining? On the disk,
Nicole, can you just open the windows? What you think of? I'm trying. I'm sorry. Let me know if you need help.
Of rotation. Hence, see page 272 of physics book.
Okay. That was 20 points, Mr. Brown. Thank you for reading that. So, what do you need for your first notes? Well, some of y'all might have already known because I saw y'all writing it down. You got to use some Greek letters in some cases too. We're talking about page 271. All right. Crack your book open to 271. You need this box typed out the same way. It'll take care of this first section of your notes. Right? I'm just explaining more. So all you need to get credit for that first part of your notes is this little box. Everything in that box, green with the orange bar, type it down. Okay? All right, I'm going to start working it out up here. But you need to first start typing that while I'm writing it up. So, the name of this is called tangential speed of a rotating object. This is found in the middle of page 271. This is part one of your notes, so you can order them all the way down, right? So what do we got? Well, we have V sub T. If you don't know how to do subscripting, let me know. I'll come and show you. Yes, you have to type it the same way as it is in the box. No cutting corners. You lose points if you try to do that. All right, so type everything, because some people will try to, I'm going to turn it in, he's not going to check it. You're dead wrong. I'm going to check it, and I'm going to take off points for everything you try to not do. All right, so look, V sub T is equal to R, which is your radius, times omega again. We talked about omega as a Greek letter yesterday. So R is radius times omega. This is times. Some people are like, what is that? That's don't put an X there, okay? That's not engineering notation. That's baby math. You have to put the star because in engineering, that's what they use. So sorry. All right, now, what are these measured in? Well, velocity is always measured as a ratio in terms of meters per second. Moving on, we have our radius. Now, when we talk about our radius, in most cases, you can't measure anything else but meters. Now, centimeters, kilometers, nothing, just meters, right? So you got to convert it. So in this case, we always keep in mind we measure it in terms of meters. You do not have to put the arrows and everything I'm doing. I just ask that you put everything in that box on page 271. So if you're trying to tell me, ask me what I'm writing, that means you didn't open that book up. Okay. Omega. This is not W. If you need help putting that character in, the Greek letter omega, not W, ask me, Nicole, or Jamel. We'll show you how to insert that. All right, what is it measured in, right? If you don't remember, last time I said there's two ways to measure omega. You got radians per second or rads per second for when you do radians, and then you have revolutions per minute when you do degrees. All right, so in this problem, we're going to refer to it in terms of radians or rads per second we're calculating. All right? So we look at cross sections of this. This is measured, it's called omega, but it's measured in terms of either rads per second for radians short, or RPMs or just write it out, revs per minute. All right? Now, we're done with part one of your notes. All you need to do is type what's on 271 in that box. Okay, I heard him. He said no movement. That means no water, no breathing outside in the hallway, no talking in the hallway. Stay right here. That's what that means. No, yeah, I hear you, man. I know you like to talk, but let's get this done. Number 2 of your notes. No. What do we know? Versus, what is the question asking you? Okay, so let's keep it moving. We look at our problem, and there's a lot of steps to this, so I hope you're writing it as I'm typing it as I'm writing it. Okay, I'll put a picture in Esby, but if you just chit-chatting and cracking jokes or taking a nap, it's going to be a problem for you later. All right, so we start off with the variables they gave us, right? So we go back to what Jamarion read. That was, it says, it must be maintained at a speed. That's your clue. Speed, hint, hint. That's your V sub T, your tangential speed. So you're going to write V sub T is equal to, and you put the value they gave you. So it's, in this case, 7.49 meters per second. Okay. Moving on. We got a part A and a part B to this problem. By the way, if you ever get confused, the problem is located, how to do it, all steps. Well, not all steps. They will show you all steps. But it at least gives you an idea on page 272 if you want to take a look at what we're calculating and why we're calculating it. All right, there's a little picture here. Shows you a disk. It shows you why we're doing a calculation on this disk. All right, that's the problem. The name of the problem is, again, playing a CD. So let me hurry on because we don't have a lot of time. Part A. In part A, you need to find, in the problem, one of the radiuses, I think, right? So your radius starts at 8.68 centimeters, right? So we say R for part A is 8.68 centimeters. We cannot use centimeters. We have to convert that. Now, if you're not, real sharp on centimeters, meters, centimeters, kilometers, so on and so forth, don't worry about it. I'll just tell you what it is in this case so we can convert it easily. Centi means 10 to the negative 2. So let's do that. So we're just going to change it to a meter by doing this conversion. Radius is equal to 0.68. That is times 10 now to the negative 2 meters. That takes care of that one, because remember, we cannot use centimeters. We have to use only meters. Part B. Radius is new. In the problem, they give us now 9.49 centimeters. Got to change that too, right? So we got to go here. And then I just convert it. And remember, centi means times 10 to the negative 2 meters. Okay? You gotta have all these steps, all these elements. Yes, ma'am. Second what? You talking about this?
Yes.
Part A, and you just put arrow, but you tell what it is. Part A is R equals radius, okay? 8.68. I'm taking this from the problem, y'all. 8.68 centimeters. So cm means centimeter, but we can't use that. So we gotta convert it, and then centi, like I said, turns into 10 to the negative 2. That's what it is. All right, I gotta keep going. Great question, but I don't want to make sure y'all have everything so you can do what you do on your own. So I think Nicole and Jamel got y'all.
The first one I already answered.
You're gonna be able to see it once I take a picture. So you gotta let me finish. What's the next part? We got unknown. Now we gotta do the unknown twice, but we gotta do some algebra to get there. So omega, right? And part A is what? That's what it's saying. All right. This is not W. This is omega. It changes because there's a different radius. Right? So part A. Part B, though, is going to require you to do the same calculation of that radius. Both of these are measured in terms of rads, like I talked about for a second. Please not the same way documents, so it looks neat. All you do is just say so over your unknowns, okay? And those are not W's, those are omegas. Please put it in. set tackle part A. I already told you what it is. We just write it out. We're going to solve for omega, not W. And we're just going to do some algebra. You'll be saying W, but omega by itself. So I'm going to write it out and solve it. So let's do it. It's going to be, what is the equation again? B sub t is equal to the radius that's given, part A, multiplied by omega. We do our algebra, right, technique, and it's a one-step algebra problem, so all you got to do is remove the r, or radius, next to our omega. So to do so is multiplication, I do division. That's how algebra goes. What you do to one side, remember you got to do to the other. So go ahead and do that. I have basis and rewrite my equation, plug in my numbers, and part A is done. So let's do that. All right. What do I have here? I got omega now. Just rewriting the equation is equal to our tangential velocity divided by our radius. Now plug everything in. Omega is equal to, this is so that's 7.5 meters per second. All divided by, we have a radius down here, and this is going to be the centimeter value, right? So at the bottom you have 8.4969, and you do calculations that have all the steps in y'all. So the corners. And now we're ready to calculate this and then move on to part B and be done with this. So y'all gotta show conversions. I need to step after these R's, y'all. Who did this? Nicole, almost. I think those numbers might not be right here. You didn't convert your centimeter values. You just probably put those numbers in. The times 10 to the negative 2 has to go in each of those R's. You can't use it. That's what I was telling you. You got to put that in there because that's part of the calculation. Sorry. I mean, you close, but you just got to convert those two radiuses.
So I can put
Use for both of those calculations. Yeah. All right. No problem. Close. All right. Almost through. So, what is our omega here? What is our velocity? Or speed? What is it? We go here and calculate. I previously calculated we use the gradient of degrees versus radians. So for radians, you just get the power button and then make sure if you want here it says radians now. So you go to settings at the home screen, document, you tripping. Document settings, and you see it says degree. I'm gonna change that to radians now. Right, and you can go gradient too, but we're not doing that much. All right, come down, make my default this, and now when I calculate stuff, it should only be done in radians now. If you need help changing it back, let me know. Well, let me finish this up because we're running out of time, and I'll take a picture and put this in SB for those that got to do it for homework. So what do we got? Use my fraction button because it's easier to keep all these big numbers grouped together. 7.49 come down. That's going to be 8.68 times 10x. We raise it to the negative 2, and I get 86.29. And that's rats per second. Box that off. That tackles part segment of your problem. So again, we're going to solve for plug in your numbers because we did all the algebra before. once in per day. So now, like I said, this is really, really done. So take the same calculation and change just the radius at the bottom. Make sure times 10 stays at the bottom with that. You need it. That's what centimeters. So it's going to be 9.49. Right? And then I hit enter. And now I get 78.93 rads per second. All right, I am going to try to tonight. Got time between meetings, the YouTube link to the video, and also a picture I'm about to post now. That's it. For robotics students, if you notice, there is a video in there of yesterday's what I did and a picture. You use both. You want to hear something.